All right, we'll start on assignment 5.2. We're going to talk about power. So this will be an introduction on the idea of power. So usually I start off with the fairly simple observation that if me and some guy from the NFL, linebacker or something, weighs about the same as I do, were to climb a flight of stairs, the amount of energy we would exert is mgh. So that would be the amount of energy we would exert. Potential energy is equal to that, right? So climbing a flight of stairs, we would take our masses, let's say 100 to make the math easy, 9.8. Let's say the flight of stairs is 5 meters tall. So that would give me 100 times 9.8 times 5. 9.8 times 5, and I get a whopping 4,900 joules. 4,900 joules. And we'd note that both me and the NFL player would have the exact same energy. So we would say we're both equally energetic. For some of you, that's really bothers you because you're looking at that and saying, wait a second, an NFL player is like a pro. He can run up those stairs a lot faster. But if we ask faster, we said how much energy. The same energy when we get to the top, I might be wheezing, but we both got there at the same time, so we do have the same energy at the top of the stairs. So what you want to talk about is something different. And the idea is an idea invented by a guy named Watt. Now, Watt had a problem. Watt had built a device that looked only in your nightmares like this. Well, I had terrible little smokestacks. And he had a little train engine. Didn't have a cow catcher because back then he wasn't worried about cow catching. And he built himself a railroad. Now, the railroad was really nice because it ran on coal and could carry an awful lot of stuff. The problem was he didn't have any way to explain how good it was. So he invented the idea of power. Now, power had been a word that had been used for a long time, but his idea was that his engine was more powerful than a horse, which was what he was trying to compare it to. In fact, his was how many horsepower. Okay, and so he basically said, I can deliver the same work done, but in a much shorter time. So he decided that power had to be the amount of energy you deliver divided by the time it takes you to do it. Okay, so power is energy divided by time. So we'd say that because an NFL player gets up there in 1 second, it takes me 15 seconds to get a flight of stairs, that he would be much more powerful. He'd be 15 times more powerful, even though we have the same amount of energy. Right? We still delivered the 4,900 joules, okay? But in his case, he did 4,900 watts. By the way, watts is a joule per second, and we name it after Watt because, after all, Watt invented the idea. And if I did it in 10 seconds, I know I said 15 seconds, but I'm doing math easy, I get 490 watts. And so I'm only at 490 watts where he's 4,900 watts. He is more powerful than I am. So power is energy divided by time. We're going to measure in watts, which is just a joule per second. And so the example problem we have here, example number 4. Example number 4, where's my pen? There it is. Example number 4 is I've got a heavy trunk. I'm sliding it up an inclined plane. I'm applying 500 newtons to it. No, yep, 500 newtons. 500 newtons to it to slide it up an inclined plane. Inclined plane has we have an inclined plane at the height of 1.5 meters. So 1 point, do I have an angle? Yeah, 1 point. So this is 1.5 meters. And then this is 30 degrees. 30 degrees. Okay, so to figure out how much energy, I would do power equals energy divided by time. I wonder how much energy the pushers provide. Well, the pushers are pushing it up the inclined plane, right? So they're doing force times the distance. So I'd have to figure out what this distance is. To figure out what this distance is, I would then use sine of 30 degrees is equal to the length of the 1 point opposite, 1.5 meters, over the length of the board. I do some math. I get 0.5 times L, because sine of 30 degrees is 0.5, is 1.5. Get the length of the board is 3 meters. So then the power would be equal to work divided by time, which is going to be equal to force times distance divided by time, which is 500 times 3 divided by time it takes to do it according to the problem. It takes 4 seconds to do this. So I would get 500 times 3 divided by 4, and I would get 375 watts. Okay, so more powerful a bulb, the brighter it is, the higher the wattage. Okay, and that's the way the game is played. Okay, that should do it for power. Okay, we'll go ahead and try some practice problems on assignment 5-7, which you should be able to get in the same place you got this video. Bye.